Okay. What's that? Solve our equation is. All right, you can stop sharing. That's a different one. Okay, that's good. You can stop sharing. Got it. So
Relation.
let me make something up here. Let me make something similar. I would say, I know -5, maybe 1 here. And we're going to try to do this. Let's say this is maybe 2 here. And maybe, let's say this is maybe -3. And over here, probably -6. So that's a similar shape, okay? Just moved it a little bit. I'll let you do yours later similarly, okay?
Okay.
So that's the y. Let's see here. So basically, we want to find the domain. So there's 3 questions here. Find the domain, find the range, and is it a function? Is it, or determine if it's a function. Okay, so let's start with the domain. The domain is the values of x. So the values of x extend between what and what on the graph? Look at this graph, the values of x. The values of x of this parallel.
-1 and -5.
Not -1. They go all the way, see here?
Yeah.
This is part of this, so all the way from here. And also here. This will be what? X will this be? This is 1, 2. This will be 2. So the values of x go between what numbers?
It goes from -6 and 2.
That's right, -6 and 2, inclusive. We're going to use these brackets. Means inclusive. Even these are included. If you did not include it, you would use parentheses. That's the domain. What about the range? Same way, tell me what the range is. It goes between what values?
Is it the same thing?
No, the range. So the domain is the x values. The range is the
y
values. Yeah. Look at the graph carefully and tell me what do they go from?
It goes from 2 to -3.
That's right. And you'll start with the smaller one on the right, on the left, then the other one on the right. Okay. And again,
yes.
Inclusive. We're going to use brackets. That's all there is to it. The last one, if you look at it says using the vertical test indicate if it is a function or not, or a relation. So you have this basically a graph of a relation. We don't know if it's a function or not. We do what we call the vertical line test. So is this a function or not based on this vertical line test? How many times?
What does that mean?
Okay, so how many times does the vertical line test? How many times does it meet the graph? How many times does it meet the graph?
2 times.
Twice, that's right. Once and twice. So if it meets more than once, it's not a function. If it meets more than once, it's not a function.
Can you show me what it looked like the opposite way, if that makes sense?
Yeah. So if you have a graph, for example, like this, you have something like this. If you do the vertical line test, how many times will the vertical line test meet this?
Once.
Only once. Anywhere you do it, will be only once. So this is a function. Okay?
Okay.
And this one says if it meets more than once, maybe 2, 3, or 4 times, not a function. So here, not a function. That's basically what that means.
Okay.
Okay, so remember the domain is the x values, between what values, and the range is the y values, this and above, and the vertical line test from a graph, just imagine a vertical line. If it meets more than once, not a function. If it meets exactly once, it's a function.
Okay.
Domain and range, but this time, not from a graph, but from the function itself. So let's say f of x is maybe, let's say x plus 1, maybe 2x minus 4. So when you have a function, it has a fraction. So to find the domain, or actually just the domain, not the range. Yeah, just the domain. We don't need to find the range. You have a function, you take the denominator, and you say that can't be 0. Okay, you can't have 0 in the denominator, so take whatever the denominator is and say it can't be 0, then solve it for x. So what do you do to solve this inequality for x? Just like you solve equations.
Yeah, subtract 4.
Okay.
I mean, add 4, add 4.
Mm-hmm.
The 4 cancels, right. Divide 2x over 2.
And then x is? X will be?
2.
2. That's right, not equal to 2. So for this function, basically, you can plug, as we did last time, you can plug any number you want, f of 0, f of 1, negative 1, whatever you want to plug, except for this number. It's not good to use. It's undefined. If you plug it into the function, you end up with a 0 here, which is undefined. So this 2 is basically the undefined value for the function. So undefined. Okay, and the question says write it in interval notation. Interval notation, that's right. If you want to put this on a graph or a line, it will look something like this. So basically the x values, this is just the x, so we don't need the y, just the x, because we only need the domain, not the range. So we have 0 in the middle. Basically, we can use any number from here. This goes to negative infinity. So the domain of this function is any number except x2. So the x2 will be somewhere here on the right.
Yes.
Right? And that number itself cannot be used. So we're going to use a hole in the graph instead of a continuous graph with the point. We're going to poke a hole in it. So that point is not good. But any other points in this direction or to the left is good to be plugged into the function. So that's the graph. This is the inequality. We solved it. But the question says write this in interval notation. So we're going to write 2 intervals. We're going to break this with this line into 2 intervals. Let's start with the left one. From the domain of the x goes from where to where?
2 to 0.
Not 2 to the 0. It does not stop. See this arrow? It goes to infinity.
To negative infinity.
That's right. To negative infinity. So the negative infinity. But what do we use around 2? Is it included or not?
Huh?
Is 2 included or not? Can be 2, right? So
yeah, it can't be 2.
But what do you use, brackets or parentheses? So earlier, we used, for inclusion, we used brackets, right?
Right, we use bracket.
For this one, it's not included. X can be 2. That's why we use parentheses. Okay? And also parentheses around infinity.
Can you explain that a little bit better?
So before we had a graph like this, for example, maybe from 1 to 7. Let's assume this is X. We don't have a circle here. We don't have a hole. If this was a circle, that means the 7 is not included. We would say 1 to 7, not including the 7, but the 1 doesn't have a problem. It doesn't have a hole. We can say this. Okay, so this means included. If it's not included, if you have a hole in the graph, we use parentheses. So this is not included. Okay, so for this one, is the 2 included?
No.
No, because we said it can be 0. That's why we used parentheses. Okay?
Yes.
Now the other side.
If it was included, then we would use
Yes. If this was, for example, for some reason it wasn't a circle, it was continuous like this. There was no point, no hole in the graph, then we would use bracket here instead. So bracket for inclusion, parentheses for exclusion or not inclusion. Now that's the first interval. What about the other interval? From where to where?
2 to infinity.
That's right. Again, what do we use around 2?
Not included.
Not included. That would be what symbol?
A regular parenthesis.
Regular parentheses, not brackets. And for infinities, we always use parentheses. Well, at least that's the notation of the book. So our book, we go by the guidelines of it. Other books or other systems may use different notations, but for our book, this is it. Do you know what we use between two intervals to join them, to say this and this? Do you know what?
Comma.
Not comma. Is a special symbol that we use basically to mean this and this, to join the two.
No, I don't know.
Okay, so that symbol looks like this. Have you seen this before? It looks like a U.
Mm-hmm.
Basically means union.
Unity, union.
Unity or union, that's right.
Mm-hmm.
You just join in the two, basically. So this and this. And that's the interval or the domain of the function in interval notation. So basically, the domain is all the values of x that can be plugged into the function to get an outcome that's defined as a real number in the group R. The only number that cannot be used is the 2. So the 2 will not give you a result, it will give you some undefined value. So we try to stay away from it. We will not be able to use it. Okay, that's the first one. So basically the question is this is the important part, since to write the domain in interval notation. You don't have to do the graph. You don't even have to solve this. If you can see the number right away, you can just jump to this, because that's what the question is asking for the domain. It's not easy. It's not hard to actually figure out.
No, it's not. I just, the term, I didn't Google it, so I don't know.
Unless it's a complex equation, then you may have.
I didn't look
But you can figure out the number right away, or maybe show this work just to get credit or extra credit. But the graph was not necessary, was just explaining, okay? But you might do this and this, but this is the important part. So that was number 12, right?
Yes, it was. And then number 13, I think number 13 and number 14 probably is, no. Number 14, yeah, we could do both of them too.
Okay, number 13.
Idea.
Number 13 is a different type of function. But I'm gonna make up one and I'll let you do that one later, okay?
Yes.
Say 5x minus 20. Same question, we need to find the domain, okay? The domain, also in interval notation. So here's the difference. When you have a fraction, the bottom can be 0. But when you have a radical, what kind of numbers you can't have under the square root?
I'm sorry, say that again.
What kind of numbers, what type of numbers we can't have under the square root?
What kind of numbers can't we have?
Yeah, that we can't have under the a radical. It's a certain type of numbers, certain sign of numbers that we can't have under the square root.
Is it negative?
That's right, we can't have a negative here. The result of this, the outcome of this can't be negative, but it can be 0. So it can be greater than or equal to 0. Okay, the inside here, whatever it is, let's call it A. So A has to be greater than or equal to 0. Whatever x you plug in, the outcome of this should not be negative, because that would be undefined. It's not a real number. You can't have something like this. It will not be a real number. It will be undefined. It will not be part of the R group. So this will not be in the group of real numbers. Group of real numbers basically means this, all the numbers negative, positive, not including the complex number. So this is not an R, it's a complex number. But in our class, we're talking about real numbers only. We're not dealing with complex numbers. So that's basically when you see a radical, a square root, you say the inside must be greater than or equal to 0. But what number would we start from to start getting only positives and not negatives? So to do that, we'll have to solve this. We'll have to find the number. We start from 0, so 0 and up. What number would give you 0 inside this radical? What value of x will result in 0 here?
I don't understand.
Okay, what value of x If you substitute, if you put x here, what value of x would make this 0?
0.
No, if you plug 0 here, it would be 5 times 0 would be 0. The outcome would be negative, which will be undefined. Think again, the whole thing. To get 0 here, what is the specific value of x? If you plug
1.
it, nope. So 5x minus 20, it's 4. It's 4. 4 times 4 is 20. 20 minus 20 is 0.
Yeah.
So let's see how to get that number. Let's say if you can't see it for some reason, let's see how to get it actually. So you're gonna need to solve this. And as we said, it has to be greater than or equal to 0. Okay, whatever this is, must be positive or 0. Unlike here, we say it has to be, it can't be, we use not equal to. So this symbol is not equal to, but this symbol here is greater than or equal to 0. So we use that with square roots. And then you solve the inequality, same way we solve equations, or same way we solve this. What do we do first?
Add 20.
Add 20. So 5x.
Cancel, 5x. And
That's
the answer is 5 going to 24.
That's right. So x is greater than or equal to 4. That's why I said 4 earlier. Like I said, if you can see the number right away, that's good. You can write the domain. If not, you can always solve it. So now let's write this on a number line to make it to write the interval notation. It helps to write the graph first. You don't have to do the graph first. You can write this right away. What do you think the domain is the interval notation before we do without 4. Doing? So between what and what? The x goes
0 and 4.
Not 0 and 4. X greater than or equal to 4. So the 4 will be here.
Yes.
Right. So where do you go to make this statement for this inequality true? X greater than or equal to 4. So you start from 4 and then you go where? To the right or left?
To the left.
We want the numbers that are greater than
4. 4. So to the right.
To the right. That's right. So any number that's 4 or higher is okay to plug here, to be plugged here, because it will result in 0 or higher. Any number less than that, any number less than 4 will not be okay, because if you plug it, you will end up with a negative end of the radical, and that will not be a real number. It will be some other type number, complex number, for example.
Yes.
Okay, and let's write this in interval notation like this. Just one interval. From where to where, the x?
From 4 to infinity.
That's right. Is the 4 included or
not? You said what?
Is the 4 included? In other words, do we use a bracket here?
Oh, yeah, definitely is included.
It's included, good, because we don't have a hole here, and it's fine to use 4. It's fine, because if you use 4 here, you end up with 0, which is okay. You can have 0 under the square root, so you're going to use a bracket. So that's what answers the question itself. Again, if you can see it right away, you could write the interval right away, okay? You don't have to do all this.
Okay.
Maybe you could do this, probably.
But for 13, I think I put 2. That's what I got. I put x is greater than.
In your example, probably.
Yeah.
Let me look at it again at 13. Not 2.
3.
3. That's right.
Yes.
3 to infinity. Yeah. Okay, last one, 14. It's another function, but it's a little bit different than the others this time. Okay, this one is a radical, and that radical is in the denominator. Let me write it out. All right, so this one, let me use different numbers. So f of x, let's say, okay. I'm not going to use the exact same thing, but I'll change the numbers a little. Let's say 1 minus 2x over square root of maybe 9 minus x squared. So we need to find the domain. domain so this one's a little more complex than the other two. Basically, this combines the two. So first, the denominator can't be 0, right?
Oh.
So what's the denominator here? This whole radical.
9. Okay, 9.
Including the radical.
X.
So you say the whole thing can't be 0. Not only that, since we have a radical, the inside has to be what?
A real number.
A real number. Well, in terms of the signs, the inside must be, look over here. The inside of this can be, it can't be negative, right?
Yeah, it can't be negative.
That's right. That means it has to be
0 or...
That's right, 0 or higher. Okay, so we have two restrictions here. So first, this gotta be 0. So if you put this on a graph, so first, we can only take, so this is infinity, negative infinity, 0. So first let's figure out the sign of this. Now, what's under the radical must be greater than or equal to 0. Okay, yes. That's what we said earlier. Then we're just gonna need to solve this to find or to decide which values will give you positive numbers. Okay, so if you solve this equation, it will be something like this. If you solve by factoring, it will be 3 minus x and 3 plus x, right?
Yes.
So what is the solution here? X, for this to be 0, what is the value of x?
X would be 3.
X, that's right. X is 3. That's one of the solutions. And here, x is?
3.
Not 3. We want to have 0. Negative 3. So if you graph this, basically this, we want to know where does this graph become positive and when does it become negative. If you sketch out the graph like this, this is basically, these are the y-intercepts or the x-intercepts. So you have two solutions. So the graph goes through here and here. This is 3 and this is negative 3. This is what this means when a quadratic equation has two solutions. Those solutions are the intersection of the graph, the parabola. There's the intersection of the parabola and the x-axis. We call these the y-intercepts. Or the x-intercepts.
That's x1 and x2.
That's right, x1 and x2. So for these, the y is 0. So that's why we call them the y-intercepts. Okay, so these are the y-intercepts. Now we need to see the bottom of the graph, or the vertex. What is the vertex of the graph? The vertex of the graph is when the, so if you look at this graph, what is the vertex? That's when x is 0. So when y is 0,
okay.
When the y is 0, that's the y-intercept, the x-intercept. Actually, this is the x-intercept, and when the x is 0, if the x is 0, what does the equation turn into? If the x is 0. If x is 0, this cancels.
Yeah, so and it just 9. Turns into, okay.
So y will be 9. That's basically what we call the vertex. The vertex, that means the highest point of the graph. The highest point of the graph will be, for example, here. So the graph will be going like this. It goes all the way up. This is what we call the vertex. Let me use a different color for this. Not exactly that. You try again, so it's gonna go like this. And then goes down. So this is basically a negative function. That's why the parabola is facing down because of this. You have a negative 2x here. This one will always be 0 or higher, as we said here. So this is the vertex of the graph. The vertex is either the higher or the lowest point. Sometimes the graph goes up if the function is positive, so this will be the vertex, but in this case it's facing down. So these again, what we call the x-intercepts. So these are the x-intercepts, where the y is 0, and the y-intercept, the y is what we call the y-intercept, is the vertex. Let me just use a color. So this is the y-intercept. The x-intercepts are these, this one and this one. Did you have a question?
What about the top half?
Top half, what do you mean by the top half?
The one subtract.
Yeah, so here for the numerator, you mean the numerator, right?
Yeah.
So we don't worry about the numerator. It does not affect the domain. Only the bottom of it can affect the domain. What else? What was the other part of the question? Right. So D, the domain.
Mm-hmm.
Any number basically from between these two will be a positive number.
Yes.
Right? Any number, because the y, as you can see, is positive, but the numbers after this and after this will result in a negative y. So we can
say,
so -3 to 3. What the number that would give you 0? Which value of x would give you 0 again?
3.
The 3. So this one is not included because that would result in 3 in the denominator, and that's not possible. So what do we use around 3?
Bracket.
Is it included or not?
Oh, a parentheses.
That's right. Is this one okay?
No, we will use a parentheses on that one too.
Exactly, very good. Because if you plug it, it will turn into a 9, 9 minus 9 is 0. So basically, this is the only values of x we can allow for this function. Between -3 and 3, exclusive, not including the -3 and 3. The graph makes it easy to understand. If we didn't do the graph, it would not make any sense.